This is on mute.
Yes.
All right, guys. Now let's go ahead and jump in. Hopefully everyone has had a chance to download this. And you've warmed up conversation with your partner because we will work with them today. So some beginning thoughts before we look at these types of word problems. We just reviewed the equation for distance, rate, and time. And Caroline reminded us that distance is equal to rate times time. Now, essentially what we've looked at is the miles that you've driven typically is equal to your rate, so your miles per hour, multiplied by how many hours you've driven. So essentially how far someone's gone can be determined by their rate multiplied by their time that they've gone. In a very similar aspect, so go ahead and write distance equals rate times time is very similar to really the amount of work someone can do. The amount of work someone can do is equivalent to their rate of work multiplied by how long they work. For example, if you are a fast worker, you can complete your job in less time. If you're a slow worker, it's going to take you longer to complete your job. And the way to determine it is really you need to look at what is your rate? Like how fast of a worker are you? So D equals R times T is very similar to the amount of job you can do is equal to your rate of completion multiplied by your time worked. Now I know that this is new for us, so let's add kind of some units to this equation. J represents the amount of job completed. So the amount of job completed, and this is usually 1, it's not always 1, but typically we're looking at completing a job, one job, is equal to the person's rate of completion, and we'll look at that in a moment. Rate of completion multiplied by their time worked. And today we're going to look at people working on a job. We're going to look at just machinery working on a job. Essentially, we're going to look at what is the rate that someone works multiplied by how long they work. Let's start with just a more basic question. Looking at number 1, let's start with letter A. If it takes Laura 3 hours to clean her room, what is her rate per hour? So essentially, what's her rate of completion? So go ahead and look at that. I want you to just answer it on your own. You don't have to use an equation. You can if you want to, but try to answer letter A. If it takes Laura 3 hours to clean her room, what would be her rate per hour? I want to walk around just to see what you guys answer because it helps me to know kind of where we are in starting this lesson. All right. Some people were trying to use the equation. You can, I'll show you how. Some people just had the answer. Allison, can you tell me what answer you had?
I had 1/3 of room per hour.
Nice. Laura can do 1/3 of the room. I like that. 1/3 of the room gets cleaned per hour. Love it. Now, some people were using the equation. They said the amount of job that Laura can do is going to equal her rate times the time. Here's how we would use the equation to solve for the rate. The job that she's completing is one job. She's doing one room. She can do one room in 3 hours. So that would be her time. So if I'm using that to solve for rate, I would say 1 is equal to rate times 3. And then if I'm solving for R, what would I divide this equation by? 3. Divide by 3, divide by 3. And I would see that the rate is equal to 1/3 of a room per hour. Notice we took a room and divided it by hours. So it's room per hour. Now, some of us just kind of thought through it and said, well, if it takes her 3 whole hours, then she can do 1/3 of the room per hour. That's great. But we do have to be able to solve for someone's rate to be able to determine how long it will take them to complete a job. So now let's go ahead and let's take that information, use it to solve for letter B. How much of the room does Laura then clean in 2 hours? What would be the answer? Caroline?
Okay. Would it be
Oh, you're doing the equation. J is equal to rate times time.
1/3 times 2, right? That'd be 2/3 of the room.
Yeah, 2/3 of the room. Now, Caroline used the equation. Some of you I heard just spout out 2/3. That's correct, because if she can do 1/3 of the room per hour, take that 1/3 times it by 2 hours, and you're going to find that she can do 2/3 of the room. So that's kind of a way you could use the equation to solve for the amount of job that you do. All right, let's see how we can continue to use this equation. Number 2, if Eric can mow 1/3 of the lawn in 3/4 of an hour, what is his rate of completion per hour? So again, I know that the amount of job that someone can do is equal to their rate multiplied by their time worked. So how much of the job does it say that Eric can do? 1/3. So he can do 1/3 of the job. And what's the time he can complete that in? 3/4. Awesome. So if I'm using that to solve for rate, I do have to know, how do I get rid of this fraction? So you could divide by 0.75. That would work. If I didn't want to reach for my calculator, do you guys remember you could multiply by the reciprocal? So times that by the reciprocal and times this by the reciprocal. And now the 4's cancel, the 3's cancel, 3/4 times 4/3 is 1. So I have the rate is equal to multiply across. So that would be 4/9. What would be my units? 4/9 of what? Good. The lawn mowed per what? Per hour. A rate always has to have like a unit per measure of time. So if I'm looking at his rate, he can do 4/9 of the lawn per hour. Caroline.
So just like the bottom, like for example, if it's hours, middle is hours, that always has to be one.
Does the bottom have to be 1?
Yeah.
Oh, it doesn't have to be, but typically we use it. If you're using an equation, you want that denominator to be 1. Good question. Because I guess the other way that you could say this is he could do 4 lawns in 9 hours. Technically, that's true. But the rate, we would say 4/9 of a lawn per hour. So yeah, you'd want that denominator to be 1. Okay, let's keep using this idea of rate. Now we've looked at these people singularly, meaning they're working by themselves. Now let's start looking at people working together. And let's start just by answering question A. And I apologize, this looks like A period Bailey. It's supposed to be like A with a parentheses, like this is part A, this is part B, and this is part C. So part A, it says Bailey can wash and wax a car in 4 hours. Jason can do the same job in 3 hours. What is Bailey's rate of completion per hour? What is Jason's rate of completion per hour? And then who is faster? So what I'd like you to do is turn to your partner, and the person who has the more expensive Starbucks drink order. So you gotta think, what's my favorite Starbucks drink? What's more expensive? You share what you would do to find Bailey's rates. All right, Olivia, what's your price of your drink order?
I think it's like $5, just the average. Yeah.
Okay, what's your favorite drink?
Sorry, did you ask me or
Olivia, what is it? Olivia,
Oh, it's a white mocha. It's like a
nice.
yeah.
Kayla, how about you?
I mean, I sometimes get expensive drinks, but the one I get mostly is like $3.
Okay, and what is it?
It's just a ice cold brew with vanilla.
Oh, that sounds good. I usually get just coffee with like white mocha or with like toffee nut. They used to have it. They haven't had it lately, but toffee nut and steamed cream. And it's kind of like, yeah, it's cheaper and then it still has that sweetness to it.
That's nice.
Okay, so Olivia, I think
Yep. Yeah.
on that one. So what would you do to determine Bailey's rate?
So you would set it up J equals R times T.
Nice.
And then you would do it would be like L equals R times 4.
Okay.
And then you would divide by 4. Yeah, both sides. And then the rate would be 1/4.
Nice. So 1/4 of the car per hour, right?
Yeah, car per hour, yes.
And then what would Jason's rate be?
So you would set it up similarly. It would be J, yeah. And then it would be
Times, he can do it in 3 hours, right?
yes, yeah. And then you divide by 3 on both sides.
Nice. So his rate is 1/3 of the car per hour.
Yes.
And who's faster?
It would be Jason.
Nice. Nice. All right, guys. Let's see what you got. Did you get that Bailey's rate was 1/4 of the car per hour? Jason could do 1/3 of the car per hour. And did you get that Jason is faster? Yes. Okay, one thing I want you to make note of. Notice that someone's rate can typically be found by taking the one job divided by how long it takes them to do it in. So Bailey can do one job in 4 hours. Jason can do one job in 3 hours. That's something that'll be helpful on the next page. Okay, now, given the information above, how much of the job will be complete if Bailey and Jason work together for 1 hour? So now we're working together. So I just want you to make sure you're aware that now we're taking Bailey's and Jason are working together on a job. They each have their own rate of completion, but they're working together for 1 hour. Okay, so let's think about it. Bailey's part of her job, in fact, I'll add these letters, or I'll add these words to it. Bailey's part of the job completed can be found by taking her rate multiplied by how long she works. Same with Jason. Jason's part of the job completed can be found by taking his rate multiplied by the time he works. So how long are each of them working? 1 hour. So this is going to be 1 and this is going to be 1. But now what is Bailey's rate again? 1/4 of the job per hour. Plus what's Jason's rate? 1/3 of the job per hour. So Caroline said add 1/4 and 1/3, but the reason why is because if Bailey does 1/4 of the job per hour, that means that the part of the job that she completed is 1/4. And the part of the job that Jason completed is 1/3. So Bailey does less. She does 1/4 of the job. Jason does more. He does 1/3 of the job. How much do they do together? 7/12. Exactly right. Because we need a common denominator. We'd multiply that by 4 over 4, this by a 3 over 3. So the answer is 7/12. So I'd say 7/12 of the job they did together. So essentially what we're doing is we're taking Bailey's part of the job plus Jason's part of the job will equal the total amount of the job done. Okay, and that works, 7/12 of the job. Did they complete the whole job together? No. Did they complete half of the job together? Yeah, a little bit more than half, right? So do you think that they will need 2 hours to finish the job? A little bit less, right? Because if we do 2 hours, then we'd have 14/12 of the job completed. Okay, here's how we can figure this out. So letter C, it says, how long would it take Bailey and Jason to complete the whole job together? So now what I'm looking at is Bailey's part of the job. Bailey's, her work on the job, I'll just say her part of the job, plus Jason's part of the job. We want it to equal 1 whole job. So I don't want 7/12. I don't want 8/12. I don't want 9/12. I want 12/12. I want the entire job to be done. Now, how do I figure out what Bailey's part of the job is? I need to take Bailey's rate times her time. How do I figure out how much Jason does of the job or what his part was? I take his rate times his time. And the nice thing, so I'm going to add these together, is now I know it has to equal 1 job. Now, what I'm solving for is T, because it says, how long would it take Bailey and Jason to complete the whole job together? So I'm going to go ahead and say, let T equal the time each person works. I don't know how long it is, but I know that I have to complete one job. So T is what I'm going to be solving for. Again, what is Bailey's rate? What is she, 1/4? What is Jason's rate? 1/3? Well, I'm looking at 1/4 times T plus 1/3 times T has to equal 1. I don't know what T is. That's what I'm solving for, is what is the time that each person has to work to complete the whole job together equal to 1. It's one job.
Oh, it's one job.
One job. So I want them to complete the entire job together. Now, when I simplify this equation, when you multiply 1/4 times T, if you guys know, if you multiply a fraction times a whole number, you have to put the whole number over 1. So this will simplify to be T over 4. Plus, I need to put this over 1. So that'll simplify to T over 3 is equal to 1. Now we have to solve for T. So we've been working with these types of equations. We have to multiply by a least common denominator. What's the least common denominator between 4 and 3? 12. So we're going to multiply by 12, or you can think 12 over 1. We'll distribute that in. 4 goes into 12 3 times, so this will be 3T. Plus 3 goes into 12 4 times, so 4T is equal to 12. 3T plus 4T is 7T. And then I'll divide by 7. And so T is equal to 12/7. But T represents time. So we don't usually say 12/7 hour. I would change that to a mixed number, like 1 and 5/7 hours. The key that you have to be aware of is to determine how much somebody has done of their job is going to be their rate of completion multiplied by their time worked. And if you want 2 people to work on a job, typically you're setting it equal to 1 because you're completing one job. Okay, here's the general equation you can use for working together problems. It's at the beginning on the next page. Generally, when people are working together, this is how you can use the information in the problem. To find someone's rate, it's always 1 over the time it takes them to do the job alone. So this is really referencing the rate of, I called it person A. So you could say A's rate multiplied by the time person A works. So the rate times the time A works. So rate times time plus the rate of person B. The rate can always be found by taking 1 over the time it takes B to do the job alone. So this would be B's rate multiplied by the time B works. So rate times time, but that's for person B, is equal to, your equations should almost always, in fact, I'll tell you guys for the problems we do here in Algebra 2, always should be equal to 1. Because when people are working together, they're working typically to work on the entire job together. Now, what you're solving for is how much of the job did person A do plus how much of the job did person B do to equal the one job. Okay, let's go ahead and let's start working with this equation using number 4. Number 4, one printing press can finish a job in 8 hours. The same job would take a second press 12 hours. How long would it take both presses together? So I like to start at the end of the question because it tells me what I'm solving for. We're looking for the time that each of them are going to be working, and they're working together. So
Do like the problem, like how we're doing it for problems.
the chart,
Yeah.
it's more complicated using a chart with this situation. I can show you,
Okay.
but I've taught it using the chart and I've taught it using this generic equation, and I think more people are successful using this equation. I can show you. I'll show you at the end. Okay. So let's let X equal the time each press works. Because that's what we're solving for. How long would it take for both presses together? Here's how I like to do this equation. When people are working together, I just know that it's someone's rate, which is found by 1 over how long it takes them to do the job alone, multiplied by their time worked, plus the other person's rate, which is 1 over the time it takes them to do the job alone, multiplied by their time worked, has to equal the one job. If you are more of a words person, you might want to fill that in. 1 over how long does this person take to do the job alone? How long does this person to do the job alone? Since it is already in words right here, I'm going to go ahead and just fill this in. So we'll call this press 1 and this press 2. So that's person A and that's person B, press 1 and press 2. Let's see what we can fill in. How long does it take press 1 to do the job by himself? 8 hours. So I'm going to do 8 right here because it takes him 8 hours. How long does it take press 2 to do the job by himself? 12 hours. So I'm going to put 12 right here. How long is press 1 working for? Does it say X? Exactly, X time. How long is press 2 working for? X time. So now I have my equation, I just have to solve it. And I do want to remember that 1/8 times X is the same as 1/8 times X over 1. So that's really, yep, X over 8, yep, plus, what does the second one simplify to? Good, X over 12 is equal to 1. Now the most efficient method for solving this equation is to multiply by the least common denominator. Yes, the least common denominator, well done, is 24. So I'm going to distribute that to both sides. I'll distribute this in and this in. 8 goes into 24 how many times? 3. So I have 3x plus 12 goes into 24 how many times? Twice. So 2x is equal to 24. Add those together. 3x plus 2x is 5x. Divide by 5, divide by 5, and I see that x is equal to 24/5. And I have to stop and think, what is x representing? Time? So I'm going to call that instead 4 and 4/5 hours. So press 1 and press 2, if they work together, they each only have to work 4 4/5 hour to complete the job. Caleb.
So if you're combining like anything that the formula you use to find time, like anything,
You can use it to find anything.
find things?
Yeah, in the question.
Alright.
So I want you guys to skip number 5 for right now, and let's go to number 6. Number 6 says Carl can clean a room in 3 hours. If his little sister Kira helps, she can clean, or they can clean it together in 2.4 hours. How long would it take Kira to do the job alone? So I'm going to start this with you. Let's go to the end of the problem. Let's define our variable. What would we let X represent? Yep, the time it takes Kira to do the job alone. And you do want to be specific because there's lots of times mentioned here. There's a time that someone does the job by themselves, and there's a time that somebody's working with another person. So I'm going to be specific there. Time it takes Kira to do the job alone. Now here's how I start these problems. I know that I'm working with Carl and I'm working with Kira to complete one job. And this is typically what I do. I do 1 over some parentheses times some parentheses plus 1 over some parentheses times some parentheses is equal to 1. Now, I have that equation memorized, so I fill in the pieces based off of the context of the problem. If you need to go back to the equation, go back to the equation, but on your own, see if you can fill in what should go in each of those parentheses. All right, turn to your partner, and this time the person with the cheapest Starbucks drink order. You share what you think would go in these parentheses. Michaela, did you know what would go in the parentheses?
Would it be 3 in the first one,
Nice.
And then would it be X in the second one?
Awesome. And then what would go for their time worked?
Would it be 2.4?
Awesome. Nice job. Well done, Michaela. All right, guys, let's take a look. You should have 3 in the first denominator multiplied by 2.4. And then you should have X in the second denominator multiplied by 2.4. If you had those pieces in, you had it correct. Zinnia. On the bottom, I'm not done. This was time. So I'm taking Carl's rate times his time worked and Kira's rate times her time worked to equal the whole job. The distance gone on the job, which is one whole job. And so now I'm going to simplify. And you're right. I have to see this as 2.4 over 1. So it'd be 2.4 over 3. Yep. Plus, think of this as 2.4 over 1. So 2.4 over X is equal to 1. Now, out of the denominators, 3x and 1, what is the least common denominator? What do I have to multiply both sides by? 3x. Good. Now, some of us just like to show it being distributed right away. So I'm going to take away that parentheses to show that when you distribute, you're multiplying 3x to both pieces on the left side of the equation. And then we cancel before we actually multiply. So in the first fraction, what pieces cancel? The 3's, good. And we'll have 2.4x plus, in the second fraction, what pieces cancel? The x's, good. No, we're good. So we have 3 times 2.4 is equal to, and here nothing cancels. So we have 3x. Then we start simplifying. So I have 2.4x plus 7.2 is equal to 3x. Then we subtract 2.4x from both sides, giving me 7.2 is equal to 0.6x. And then divide by 0.6. And we get x is equal to 12. So if I'm answering the question, how long does it take Kira to clean the room on her own? 12 hours. She is a slow little cookie, but she is a helper. So it takes Carl less time than it would by himself, only 0.6 hours less. Any questions on this so far? Yeah. She's like a 2-year-old. It's like, hey, just pick this up. You know, she's small. She's small. Believe me, I have small children. To ask them to even pick up pillows and put them on the couch takes way too long. Like, come on, guys. And then you have to keep refocusing their direction because they start playing with Spider-Man or Batman. I'm like, Samuel, pick up the pillows. Oh, yeah, the pillows. Clean the room. So yeah, it's a process for sure. All right, let's go back to number 5. Number 5, one computer can do a job twice as fast as another. Working together, both computers can do the job in 2 hours. So we know right now how long each of them are working. How long would it take each computer working alone to do the job? You guys know how I like to start. I start at the end to see what am I solving for. So we're looking at how long it would take each computer working alone to do the job. So let's let X equal the time it takes. This might seem funny to you, but for right now, just write the time it takes computer 2 to do the job alone. This is because we're thinking about time. So computer 2 is faster. Let's say that it takes computer 2 5 hours to do the job. Computer 1 is slower. It's twice as slow. How long would it take?
Good afternoon, all faculty and students. Tomorrow, October 19th, will be an off-campus learning day. Students, when you leave school today, please take all of the items you will need for your learning tomorrow. Your assignments will be online by 9 a.m. on campus. All of our scheduled activities, practices, events, and athletic contests will go on as scheduled tomorrow, Wednesday, and Thursday, as well as this afternoon. On Wednesday and Thursday, we will have conferences and they will be scheduled as well. So nothing will change on Wednesday and Thursday for conferences. Remember, students, we will have an off-campus learning day tomorrow. When you leave school, please make sure you take all of your items with you. Thank you so much.
I don't know, guys.
Is this because of COVID? I swear.
I don't know. I don't know what's going on. I'm assuming we'll get an email soon. I don't know what's happening. You have an off-campus learning day. All right, guys, real quick. Shh. Let's finish this problem. Let's finish this
She
problem.
was like confused or something, and she meant.
No.
Yeah.
All right, guys, real quick. I know this is really hard to focus on, but this problem, I need your attention for. It's the hardest of the ones that we've done. Shh. Real quick, refocus. So X is the time it takes computer 2 to do the job alone, which would mean 2X is the time it takes computer 1 to do the job alone. Now, here's the truth of this problem. Because you're solving for both computers, it doesn't really matter if you use X and 2X in which place. You just, right here, I'm trying to point out that the faster computer is going to take less time. That's why I have the faster computer as X. And the slower computer is going to take more time. So that's 2X. And this is because we're talking about time versus rate. Now, let's set up our equation. We're looking at computer 1 plus computer 2 are working together to equal the one job. You guys know what I like to do. I just do 1 over parentheses times parentheses plus 1 over parentheses times parentheses is equal to 1. Then I go back in and say, what pieces do I have to fill out? This is rate times time. This is rate times time. Do I know the time that each computer works? Let's see. We have to kind of refocus because that was a big announcement. One computer can do a job twice as fast as another. Working together, both computers can do the job in 2 hours. So yes, computer 1 is going to work for 2 hours and computer 2 is going to work for 2 hours. Then computer 1, their rate is 2 times however long it takes them. Well, 2X. And then this one is going to be X. Not really, because we're going to answer for both. Now, when I multiply this times 2 over 1, Caleb? Yeah. If I multiply that by 2 over 1, what happens with the 2's? They reduce. So I have 1 over X plus here, this is going to become 2 over X is equal to 1. Now, what's the least common denominator here? X, good. So we're going to multiply this side by X over 1 and this side by X. Distribute that in. So here the X's will cancel. So we'll have 1 plus, here the X's will cancel. 2 is equal to X. The easiest question of the day, what's 1 plus 2? Oh, sadness. 3 is equal to X. You were close, Allison. So the time it takes computer 2 to do the job alone is 3 hours. The time it takes computer 1 to do the job alone is 6 hours. Exactly. Yes, well done. All right, here's the thing, guys. Based off of that announcement, I